We're now going to walk through an example where we're going to evaluate a Riemann sum. We're going to evaluate the Riemann sum for a function f of x is equal to 2x minus 4 over the closed interval from 0 to 3 using 6 subintervals, and then taking the sample points to be right endpoints and then left endpoints. Just to make things easier, over here on the right, I've written down the formula that we need to use to evaluate these Riemann sums. I went ahead and graphed the function y is equal to f of x, which is equal to 2x minus 4. And I broke up our region into 6 subintervals. Notice that our values of x go from 0 to 3. We're going to start by calculating delta x. Our delta x is equal to b minus a all divided by n. So this is just 3 minus 0 divided by n, which is our number of intervals. And in this example, we have 6, so we're going to divide it by 6, and we get a value of 1/2. I'm going to highlight that because we're going to need that in a minute. Let's first find the Riemann sum when the sample points are right endpoints. Since we have 6 subintervals, we're going to write our Riemann sum as r sub 6, and it's equal to the sum, looking up here at the formula on the right, from I is equal to 1 to 6 of f of x sub I star times delta x. And our f of x is equal to 2x minus 4. Since we are using right endpoints to calculate the height of each rectangle, that's these points right here, we can say that x sub I star is just equal to x sub I, and the formula for that is a plus I delta x. A is our left-hand endpoint, which is 0, so we just have I times delta x, which we calculated to be 1/2. So this is I times 1/2. And now let's see what these points are. I starts at 1, so this is going to be 1/2. And then when it's 2, we get 1, and then we get 3/2. We get 4/2, which is 2, and then we get 5/2. And then our last one is when I is 6. 6 divided by 2 is 3. R sub 6 is then equal to f at our first point, so that's f at 1/2, plus f at our next point, which is 1, plus f at 3/2, plus f at 2, plus f at 5/2, plus f at 3, and then all of this is multiplied by delta x, which we already calculated to be 1/2. Now we're going to substitute in that our function f is equal to 2x minus 4. This gives us r sub 6 is equal to 2 times 1/2 minus 4, plus 2 times 1 minus 4, plus 2 times 3/2 minus 4, plus 2 times 2 minus 4. And then our next one is 2 times 5/2 minus 4, plus 2 times 3 minus 4. And then all of that is multiplied by 1/2. Now let's add all of this up. I am going to collect all of these minus 4s at the end, and we'll do our multiplication first. We have 2 times 1/2 is 1, and then we have 2 plus 3 plus 4 plus 5 plus 6. Now we're going to subtract off our 4s. There are 6 of them, so we're going to subtract 4 times 6. And then we have our 1/2. Let's see what we get. We can add these numbers first. That's going to give us 10. And then we'll add these numbers. So that's 11. So we have 10 plus 11. And then we'll subtract off 24, multiply this by 1/2. And this gives us 22 minus 24. So this is minus 2 times 1/2. And that gives us a value of minus 1. And that's what our Riemann sum is equal to when we use right endpoints. Let's now do the same type of calculation, but now we are going to use left endpoints. Our formula is going to be the same. We have r sub 6 is equal to the sum I is equal to 1 to 6 f of x sub I star delta x, and our f of x is again 2x minus 4. Now what's changing is our x sub I star. Because we are using left endpoints, let's go back up here and I'll highlight these so you can see what they are. We're using these 6 endpoints. Our x sub I star is notated as x sub I minus 1, and this is equal to a plus I minus 1 times delta x. Again, a is 0, so this just gives us I minus 1 times our delta x, which is 1/2. The delta x doesn't change when you use left-hand endpoints versus right-hand endpoints. Let's now write down what these endpoints are. We're going to start with I is equal to 1, so that gives us 0. And then we have 1/2, 1, 3/2, 2, and 5/2. We'll squish it in there. Now let's write down what R6 is. It is going to be f at 0 plus f at 1/2 plus f at 1 plus f at 3/2. And then we have f at 2. And then lastly, we have f at 5/2. And all of this is multiplied by 1/2. Now we're going to substitute in that f of x is 2x minus 4. And we get minus 4 plus 2 times 1/2 minus 4. And then we have 2 times 1 minus 4. And then 2 times 3/2 minus 4. And then we have 2 times 2 minus 4. And then we have 2 times 5/2 minus 4. And we multiply all of this by 1/2. Now let's go ahead and let's add this up. We'll save the minus 4s for the end. So this gives us 2 times 1/2 is 1. And then we have 2 plus 3 plus 4 plus 5. And then we subtract off 4 times 6 because there's 6 of them. And we multiply that by 1/2. Let's see what this gives us. 1 plus 2 plus 3 is 6. And then if we add 4, we're going to get 10. And let's go ahead and add 5. So that's just 15 minus 4 times 6, which is 24, times 1/2. And this is minus 9 times 1/2, which gives us an answer of minus 4.5. And that's what our Riemann sum is equal to when we use left endpoints. Notice that these two answers are very different. The reason for that is that we only used 6 subintervals. The exact answer is equal to minus 3. So you can see that the exact value is between our two answers. If we use more subintervals, then our answer is going to get a lot more accurate.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.